Hello everyone, this lecture we're going to study trigonometry part 1 or lecture 1 in trigonometry. We'll study first oriented circle. What do you mean by oriented circle? Unit vectors, angles between two unit vectors, and trigonometric circle. In the first part we'll start by oriented circles, which means that choosing one of its two senses, maybe positive or direct sense, negative or indirect sense. This is called the trigonometric circle, which you took already in grade 10. We start always from positive, on the positive axis from here, which is the 0. This angle is 0 degrees or radians. And if you go anti-clockwise, this way it's called the positive sense or the positive direction. And if you start from here going down by the negative sense or clockwise, okay? And if you want to just understand it, maybe from 3 p.m. or from 3 o'clock here, if you go clockwise, so it means negative sense. If you go anti-clockwise, it means positive sense. This is what we mean by oriented circle. And what do you mean by unit vectors? A vector is called a unit vector when the magnitude of the vector is equal to 1. This is called a unit vector. The angle between two unit vectors, if we have two unit vectors like u and v, for example, we write the angle, or we say that the angle between OM and ON, or u, v, we write it like that, u, comma, v. Okay? We write the angle uv like in trigonometry, uv between two brackets like this way equal alpha plus 2k pi. If the angle between them is alpha, so we write uv equal alpha plus 2k pi, where k is a number belongs to z, yani maybe a positive integer or negative integer or maybe 0. Or we sometimes write uv equal alpha modulo 2 pi, or uv equal alpha mod 2 pi, or uv equal alpha brackets 2 pi, which is called modulo 2 pi. So we use usually this notation or this notation for any angle in trigonometric circle. Okay, in any angle in trigonometry or in trigonometric circle, we write it the angle, which is called here alpha or x or any letter you want, plus 2k pi, or we write modulo 2 pi. Okay? For example, if alpha equal pi over 3, then the angle is pi over 3 plus 2k pi, where k is a number belongs to the set z. The set z, which is called the set of integers. Trigonometric circle. In this trigonometric circle, we usually start from this point, which is, or we always start from this point, which is 0 radian or 0 degrees. Then at point B it is pi over 2. Then at this point it is pi, and at this point is 3 pi over 2, and we complete the turn to 2 pi. 2 pi is the same as 0. As measured, 2 pi is a full turn. If you start from 0 and you make a full turn, you repeat itself. It repeats itself. So it starts from 0, pi over 2, pi, 3 pi over 2, and then go back to 2 pi, which is the 0 radian. Okay? The unit circle here, or the trigonometric circle, has a radius equal 1 unit. And here in this way, OM equal 1 unit. Okay, OM equal 1 unit. And M is a point on the circle, and O is its center, of course. So if a point M on the circle XY is a point on the circle above radius 1, which is the unit circle or the trigonometric circle, then OH OM, the angle OH OM, which goes in the positive direction like this, as we said, that way it is the positive direction. So OH OM equal alpha modulo 2 pi, or equal alpha plus 2k pi, as we said, which is the same meaning. with x equal cosine alpha and y equal sine alpha. Okay? X of m is here. That's it. This is the x of m. And this is the y of m, which is here. So we say in trigonometric circle that the x-axis represent the cosine and the y-axis represent the sine of any angle on the circle. That is the trigonometric circle in general. Right? Right. Alright, trigonometry part 2. In this lecture we'll study trigonometric circular function of angle alpha and minus alpha, and then alpha and pi minus alpha, alpha and pi plus alpha, and alpha and pi just pi minus alpha. Ignore this one. So let's go here. Trigonometric circular function of alpha and minus alpha. Okay, what do you mean by alpha and minus alpha? Here I mean by this alpha, which is pi over 2 plus alpha and pi over 2 minus alpha. So trigonometric circular function of alpha and minus alpha. What do you mean by this? So if 2 points m1 and m2 have the same, are on the circle, with m1 on the circle with angle alpha, m2 on the circle with angle minus alpha. So m1 with angle alpha, m2 with angle the opposite of alpha, which is minus alpha. This is point m2. Type. We said that from the beginning, x-axis is the axis of cosine. Okay, so to find cosine, go to x-axis. To find sine, go to y-axis. So let's check m1 and m2, and let's compare the coordinates. If m1 having x here and m2 having x again here, so in the same location here, so it means that x of m1 and x of m2 are equal, the same. So which means that cosine alpha and cosine minus alpha are equal. Right? And let's just compare y. Y of m1 is here, which is positive. This is the sine alpha. And y of m2 is here. Right? Y_m2 is here, which is sine of minus alpha. So this point and this point here having opposite y. If this is positive, that's negative. Okay, so they are opposite to each other. Since they are opposite, so sine minus alpha equal minus sine alpha. As a conclusion, we say that cosine of minus alpha equal cosine alpha, and sine of minus alpha equal minus sine alpha. They are opposite. Examples, use your calculator just to check cosine minus pi over 3, cosine pi over 3. They are equal. Sine of pi minus pi over 3 and minus sine of pi over 3 also they are equal, the same. Again, tangent minus alpha is equal to sine minus alpha over cosine minus alpha, which is minus sine alpha times over cosine of minus alpha, since we used the previous part. So it is equal minus sine over cosine alpha, and we know that tangent is sine over cosine, so it's minus tangent alpha. Again, cotangent, which is cosine over sine. Cosine minus alpha is the same. Sine minus alpha is minus sine alpha, which is at the end cosine minus cotangent alpha. As a conclusion, we can write here tangent of minus alpha is equal to minus tangent alpha. And again, cotangent of minus alpha equal minus cotangent alpha. Okay? You can use your calculator to compare this and to compare this. They are equal, of course. You should get equal values. Let's check now cosine of minus of alpha and pi minus alpha. Alpha and pi minus alpha. So if m1 and m2 are 2 points on the circle with m1 with angle alpha and m2 which is here with angle pi minus alpha. What is pi minus alpha? Pi, which is till here, this is pi. Pi minus alpha, you just go pi, anti-clockwise in the positive direction, then minus alpha, then go back till here with minus alpha. Okay, so this is angle pi minus alpha, all of it. So this is M1 and this is M2. The angle of M1 is alpha, the angle of M2 is pi minus alpha. Let's compare x1 and x2 just to conclude the rules. So this is x of M1 and this is x of M2. They are opposite to each other, same value but just opposite sign. So cosine minus alpha equal minus cosine alpha, since they are having opposite in x. Y of M1 is here, y of M2 is the same location, so y and y are the same, so it means that sine alpha equals sine pi minus alpha. Yes, we can conclude them from the circle. So as a result, we can say that cosine minus alpha equal minus pi minus alpha equal minus cosine alpha, and sine pi minus alpha equals sine alpha. You can conclude the tangent and the cotangent, since here we have opposite signs of cosine and sine, so we can just write tangent pi minus alpha equal sine pi minus alpha over cosine of pi minus alpha, which is equal, use this, so it is equal sine alpha over minus cosine alpha, which is equal minus tangent alpha. Okay, so tangent of pi minus alpha equal minus tangent alpha, and cotangent of pi minus alpha equal minus cotangent alpha. It's the same way. Again, we can deduce some other rules, which is alpha and pi plus alpha. If M1 having angle alpha, so pi plus alpha is pi till here plus alpha, so add to pi plus alpha, the same value of alpha here. This is angle alpha, so pi plus alpha is all this one. So anyway, M1 is here and M2 is in this location here. If you compare x and y, x are the opposite, so cosine of pi minus alpha equal minus cosine alpha. When you just check, and if you look at the circle and you found that if x1 and x2 are opposite, x of M1 and x of M2 are opposite to each other with same values but opposite signs, so just write cosine pi minus alpha equal minus cosine alpha. Sine of pi minus alpha, again y, this is y here, and M2, this is y here, so M1 and M2 having opposite signs, so sine of pi minus alpha equal minus sine alpha. So we conclude here the rules. And tangent pi plus alpha equal tangent alpha. Do it in the same way. You can deduce that it's tangent alpha, negative over negative positive. Cosine pi plus alpha equal cotangent equal cotangent alpha, and those are the rules here. We can conclude them. Okay, so this is the trigonometric circle, and these are some rules. We have more rules of sine pi over 2 plus alpha or cosine pi over 2 plus alpha. I'll give you them as an activity just to deduce them if you want. Okay, anyway, they are written in your book with trigonometric formula sheet. In the same way, we can deduce the trigonometric circular functions of alpha and pi over 2 plus alpha. Supposing that M1 with angle alpha and point M2 with angle pi plus alpha, which is alpha plus 90 degrees. Yani it means alpha plus pi over 2. So this angle is pi over 2. So anyway, M2 is here. So if we can check here that this is cosine alpha, okay, and here which is sine alpha, this value here is sine alpha, okay, which is y. Right, we can check here that cosine pi over 2 plus alpha is here. This is the value of cosine pi over 2 plus alpha, okay, this one. Right, if cosine pi over 2 plus alpha is not equal minus cosine alpha, as in alpha and pi over pi minus alpha or the previous parts here. They are not the same values, but we can check here that this value of cosine of pi over 2 plus alpha and this value of sine alpha are equal. So cosine of pi over 2 plus alpha and sine alpha are equal in values. Okay, but this is positive and this is negative, so we can write here that cosine pi over 2 plus alpha equal minus sine alpha. So cosine pi over 2 plus alpha equal minus sine alpha. Then let's check now sine of alpha and sine of pi over 2 plus alpha. Let's just write sine pi over 2 plus alpha. How can we deduce it from the trigonometric circle? Sine pi over 2 plus alpha is here. Let me write it in different color. It is here. Sine of pi over 2 plus alpha is here. This is the sine of pi over 2 plus alpha, which is somewhere in the trigonometric circle. So let's check now. Let's guess now, or let's check, or let's find, let's deduce. How do we find it from the trigonometric circle? How do we find the value of sine pi over 2 plus alpha in terms of cosine or sine alpha? So sine pi over 2 plus alpha is here. Cosine alpha, this is cosine alpha. So let me write it just in different color. This is cosine alpha, which is here. Right? So we can check that they are the same in values. And also this is positive and this is positive, so it will be the same as cosine alpha. So sine pi over 2 plus alpha equal cosine alpha. That's it. This is the rule. And in the same way as previous, we can deduce tangent pi over 2 plus alpha equal minus cotangent alpha, and cotangent equal minus tangent alpha. Why? Since this is negative and this is positive, so the fraction should be negative. So for this reason, it is negative here and negative here. And the same way, we can deduce cosine pi over 2 minus alpha, sine pi over 2 minus alpha, tangent pi over 2 minus alpha, and cotangent pi over 2 minus alpha. They will be the same values here. We can just make a quick trigonometric circle here. If you suppose that this angle alpha with point M1, so pi over 2 minus alpha should be somewhere here, M2, right? So you can easily check that cosine of alpha and cosine of pi over 2 plus alpha, which is here, sine of alpha, which is here, sine of pi over 2 plus alpha this here, in the same way, but they are all in the same quadrant, so all positive. So for this reason, they are all positive here and here and here and here. Okay. Now let's check something else, which is the table of some remarkable angles. Some remarkable angles. We can draw a table and we can easily guess without calculator what is the value of each one. Just we can draw a table in that way. Okay, and we write the angle. We can write the angle here. We can start from, or usually we start from 0. Let me make it bigger a little bit. Usually we start from 0. The remarkable angles are 0, 30, which is pi over 6, 45, which is pi over 4, 60, which is pi over 3, and 90, which is pi over 2. Right? Later on we can do pi and 3 pi over 2. Usually we start with sine, and here cosine alpha or sine alpha. On it we can write angle alpha. We can write here tangent alpha and cotangent alpha. We start from writing 0, 1, 2, 3, 4, and then to find the angle or the sine of the angle, just we write radical, the number, over 2, radical over 2, radical over 2, radical here over 2, and radical over 2. And we calculate radical 0 over 2 is 0, radical 1 over 2 is 1 over 2. 1 over 2. Radical 2 over 2, it keeps radical 2 over 2, radical 3 over 2, it keeps again radical 3 over 2, radical 4 over 2, which is 2 over 2, and it is 1. So we have the value 0, half, radical 2 over 2, radical 3 over 2, and 1. Okay, so let me highlight them. 0, radical half, radical 2 over 2, radical 3 over 2, and 1. Okay, now to find the cosine, just write the opposite of them. Yani 1, radical 3 over 2, radical 2 over 2, half, and 0. Okay, to find the tangent, we write sine over cosine, so 0. Sine over cosine, we just simplify, so it will be 1 over radical 3, which is radical 3 over 3. Sine over cosine, which is 1. Here is radical 3, and here it's not defined. And the cotangent, sorry, here I wrote it by mistake. This is the cotangent. The cotangent alpha. The cotangent alpha, just when you write tangent alpha, the cotangent alpha are in the inverse. The inverse, which is not defined, radical 3, 1, 1 over radical 3, and 0. Okay, those are the remarkable angles mostly used. Okay, mostly used. Now we still have some, if we can add here, we can add pi over 2, we can add pi and 3 pi over 2. Pi, sine 0 is 0, so sine pi again is 0. So we write 0, 0, 0, 0. We can just remind them by this way. 3 pi over 2, it is minus 1, not defined, not defined. Just we can make a way to revise or to remember this all those by just easy way, starting by 0, 1, 2, 3, 4, and just you can deduce each row from the previous, that's all. That's everything in the lecture. Now I just give you some time to solve the exercises. Those exercises we can make them later. Exercise 1, just simplify. Exercise 2, simplify the following expressions. Exercise 3, exercise 4, or exercise 5. Okay, it's given some equations like that. So I'll give you some time to solve them, and later on we make a video just to solve exercises. That's everything. I hope you enjoyed the video, and just revise, watch all the video and revise them well. Watch all the video, I mean twice and 3 times, 4 times, and ask me at any time if you want to ask for any question. Thank you.